So, Michael, you're first up. Can you just
Okay.
introduce? Just introduce us to yourself and about your project, and we'll go from there.
Sure, sounds good. So let me pull it up on the screen. So, 1 second as it comes up. Okay, are you guys seeing this?
Indeed, yes.
Okay, great. So yeah, my name is Michael. I built this project called Chaser for the ETHOnline Hackathon. And so initially this idea I thought of when I was working at Masari on their subgraph project last year. When I was learning how the graph protocol worked, I always thought that, it'd be very interesting to take some of this data that you can index in the subgraphs and bring it on chain. And so Chaser is like a DeFi implementation of this where we can create these advanced investment strategies using this index data. So we have access to more granular, specific data on all these different protocols. We have historical data, and so Chaser kind of opens up these possibilities. And so this project, obviously it won the top prize for UMA, and then a couple others like Spark and Chainlink. So the problem that that Chaser solves is that the strategies that we can currently build in DeFi are very limited. Like, we don't have access to historical data, and we don't have statistics on positions and cumulative values, and these kinds of metrics usually aren't recorded in a smart contract. Like, for gas optimization and for performance, we usually don't design the contracts to record these things. And so if you're building some sort of investment vault and you want to compare different markets for investment, you can't these kinds of things aren't on chain to analyze. And even between protocols, like even if there's let's say some DeFi protocol does record these things, well, between protocols it's not standard, and it's not you can't really compare one to the other because you don't know how it's measured. And also, as we are in this increasingly multi-chain world, you can't access other chains, and you have to really implement bridging, CCIP, and all these other tools in order to access investments across chains. And so, to summarize, strategies for investment are very limited on chain. And so, you can compare even the same protocol deployed on different chains, the yields that you can get from depositing your USDC into Aave Arbitrum versus Aave mainnet, they vary. Imagine looking at this at these graphs right here. Imagine if you could choose between those two, or rather you could deposit your funds and between those two markets get the best possible yield between those two markets at any given point. And so that's the premise that Chaser is working off of: get the best possible yield for whatever sort of investment that you want to make. And so Chaser enables some more advanced strategies. So using index subgraph data and bringing the analysis of this data on chain, we can make possible different strategies that were inaccessible. And so you can set custom parameters, and you can better manage risk. And DAOs and different protocols can use Chaser in order to make a return on their unused liquidity to whatever in whatever environment that they feel most comfortable with. And so some of the strategies, just as an example, could be deposit my funds into the market with the highest yield, but also has the lowest volatility in the last 60 days. Or, move deposits to the market with the highest yield, and there's no deposits that make up 10% of the total value locked. There's a risk of a whale withdrawing and messing with the yield that you're getting. And so you have a lot wider set of different strategies that you could deposit your funds, and Chaser will move your funds between these different markets according to how you see fit. And because it's based off of subgraph data, we have all these different standardized subgraphs from Masari of all these different protocols on different chains that we can potentially make compatible with this system. And so, just to show what the project looks like for the sake of the hackathon, this is the front end that I built. But in production, Chaser would probably be a system of smart contracts rather than being like a user-facing protocol. But here's I'll get into a little bit of how the process works for determining whether or not an investment should be moved to a different pool or if it should stay in the current pool, because this is really where the optimistic oracle is used and where it really makes all of this possible. So we start with some sort of investments or rather assets deposited into a pool on Chaser. And so that could be from a user or some sort of protocol that wants to take unused liquidity and earn a yield on it, or even like Spark in the case of the hackathon, making a subDAO to take these funds and make an investment on them. And in this pool, there's a strategy contract, and this strategy contract contains logic as to how to compare between, we have this market, and this market is making a certain yield, and somebody proposes a market, and this yield is better, and according to this strategy, the new market is a better investment. There's this contract contains logic to make that determination. I'll get into a little bit more of how that works later on, but that's what you start off with. You start with assets to be invested, and with a strategy contract that determines how what is a good investment. And so from that starting point, then a user, or the asserter in this case, will call a function on Chaser that will open an UMA assertion, essentially stating that this different market is better than this current market where we're holding deposits. And so let's say, okay, currently our deposits are on protocol X, and it's in this pool earning 3% yield, but protocol B, or protocol B has a higher yield, and it also fits better with our current strategy. So they make that assertion, and now then this essentially will be taken to the optimistic oracle, and with this assertion we will determine, disputers will take the logic that is used for the strategy to determine whether or not this proposed market that the asserter has put into this assertion is actually better for this investment. And this JavaScript logic will be, it'll return the value of the better pool. And so it's up to the disputers to see what the output of this logic is. Okay, is the proposed pool better than the current pool? If so, leave the assertion. If not, then dispute the assertion. And obviously, if the assertion is true, then that means the asserter made a valid proposal saying, like, okay, this market on this other protocol is earning a better yield and follows the guidelines of this investment better than the current market, and therefore the funds are moved. And just to get into a little bit of how UMA is configured in Chaser, there were a lot of considerations when I was making this implementation. Like, especially at first, one of the big concerns was that would we be able to have the assertion settled in a short enough time frame that the investment can stay viable? Like, obviously in DeFi, yields and pools, like all these different things are very volatile and can change in a matter of minutes. So if somebody says that, oh, the yield on this pool is better than that pool, it might be true right now, but in 5 minutes it could be completely false. And so, if we're talking about an assertion period that's like a day or so, that wouldn't work. But in this case, the minimum liveness period, or the minimum recommended liveness period, is 2 hours. And I think that fits well with what Chaser is trying to do, because if an investment, if someone can assert that investing your funds into this pool is a better investment right now, and then within the next 2 hours that statement holds true, I think we can be pretty confident that that pool will is a worthwhile investment. It's worth the gas and all the other fees to transfer these funds, to withdraw from the current position and move to the new pool. That's a good enough period where it's we're confident in this investment, but also it's not too long where it can make it, it's frequently unviable just after time passing. And so that's the liveness period. And the bond is also set high because we want to have disputers constantly monitoring for these moves and acting within a short period. Like, it would be very it wouldn't be good if we had different proposals being passed through without any sort of dispute, just because of the fact that nobody was able to verify it within a short time frame. So the bond is set high just to make sure people are always looking out for it and are rewarded if they catch someone making a fraudulent or erroneous or just a bad proposal. And but that leads to another question in design. How can we prevent penalizing users who propose a legitimate investment but the investment becomes unviable during this window? And so that's something I would still have to sort out. But for the sake of the hackathon, it was sufficient just to change how the assertion is worded, that if somebody makes this proposal, the assertion isn't, you can't dispute it just because the assertion isn't valid right now. Rather, the assertion is that at this given moment that the user is opening the assertion, is this investment better than the current investment, if that makes sense. And so, yeah, I also put a lot of thought into how the disputers have to go about their process in order to verify, is this assertion true, or should I open a dispute? And so for the hackathon, the way that I designed it was that essentially this strategy logic that I mentioned before, it's a string of JavaScript stored on a strategy contract. And so the disputers have to read this string and then execute it locally. And what this logic does is it essentially makes queries to the subgraphs related to the protocols for the current pool where deposits are held, and then the proposed pool where the asserter is saying the better investment is. And then it processes the data according to the strategy. Like, it'll take all this time series data from these subgraphs and then, let's say, calculate, okay, based off of how much, based off of these different metrics, what the coefficient is for its volatility. And then it will make an objective, measurable return. It'll make an objective and measurable. It'll tell you which pool is better objectively. And obviously, this isn't the perfect way to let disputers execute this validation. There could be some better, more modular environment, like off the top of my head, putting it into like a Docker container and having disputers execute it, download the container and execute it on their local machine. It would be a lot easier than just copying and pasting JavaScript and putting it into Node. Like, there's better ways that this could be facilitated for the disputer. And on the other end, how does the asserter interact with Chaser? They are always going to be monitoring for better investments according to these different strategies. And so, perhaps they could automate this and build a monitoring service that will query the different subgraphs and then perform the proper analysis on their data to determine, what is the best out of all these different protocols, which one is the best at this moment, and then they open the assertion. And I designed it so that the asserters do not need to have deposits in the pool in order to make the assertion, because any third party, if they make a valid assertion, why not transfer the funds? Why not move the funds to this investment if the assertion holds up as true? And the asserters they're incentivized by earning a percentage off the top of all yields earned in the pool while it's in that market that they proposed, if that makes sense. And so why did I choose the UMA Optimistic Oracle, and why do I think it was the best for Chaser? I considered a bunch of different options, and I actually initially started this project using Chainlink functions, but the more I thought about it, the more it made sense to use the UMA Optimistic Oracle. And a big reason for that was because of the fact that when you open an assertion, there's a level of human scrutiny. And so the disputers can make Chaser more secure by monitoring for unexpected or suspicious assertions, or there's a level of there's this level of scrutiny that you can't get from just somebody submitting a request through Chainlink functions and having the code execute. There's another level of security there, and it's also just easier to enforce guidelines and rules that aren't necessarily like executed based off of logic, like just something that's non-metric. And it also allows for investment strategies that need a certain level of human interpretation. Like for example, let's say somebody wants to make a strategy that gets the highest yield, but cannot be on a protocol that has suffered a hack before. Now, there's probably some ways that we could examine subgraph data and, looking at different snapshots of this protocol over time that, okay, maybe there was a hack here. Maybe we could determine that based off of indexed data, but it would be much easier in the assertion to have that condition and then have disputers say like, oh, wait, this protocol was hacked 2 months ago, and they provide their source as some sort of news article or whatever. So it's much more flexible for those kinds of strategies as well. And also the computational limits are really non-existent, like up to the point of what the disputers are willing to execute. Like if there's a good enough incentive, the disputers could be running some sort of validation script that takes 2 minutes to execute, and it's making 50 different queries to different subgraphs. If the disputers are willing to do it, there isn't necessarily a computational limit compared to Chainlink functions. And so the execution environment is really wide open, and so you can really build out some different strategies and different verifications. And a little bit more into why I decided that the optimistic oracle was better than automated oracles. Like I said, it was initially built for Chainlink functions, but there's a lot of moving parts. And even when I got the functions to work, for every successful query that I made, there would be like, at least 6 or 7 times that it would fail just because of something in the middle wouldn't work. Like anybody who's queried subgraphs, they know that frequently you'll get just like a failed to fetch response. And so, there's times where that will happen, and then you would have to make another call to the oracle, and the error feedback, even if the query is successful, the error feedback usually it isn't very helpful. And so it's incredibly hard to design around that, and it's not it's much easier for disputers. If they get a failed to fetch response, they can just run the code again until they get a valid response from the subgraph. And so the automated aspect of this just isn't it makes user experience much worse, and there's a lot of wasted time. And the whole draw to having the automated oracle was that it could automatically verify these assertions within a short window of time. But if you have to make 5 or 6 different queries, just because they keep erroring out, then it defeats the purpose of having the automated oracle over the optimistic oracle. And the computational limits are also, it's not very wide. Like I don't remember how many exactly, but there's a limit to how many API calls you can make. There's a very short window of time that's allowed for execution before timeout. And so with those different factors, a protocol like Chaser makes a whole lot more sense with UMA. And also, I haven't gone too much into like the technical, like how the contracts work and all that, but because Chaser seeks the best investment through different protocols, it's also interchain. And so Across was the logical integration for this, just because there are low gas fees, the execution time, like the time to bridge your assets, is very short. And so this Across was an essential component in allowing Chaser to make investments, reach the best pools no matter what chain they're on. So you could be using Aave v3 base, but somebody asserts that compound Ethereum is the best investment for this strategy. Chaser can withdraw the funds from Aave on base and then send it through the Across bridge. And obviously there are some questions about like supported networks and what assets are supported, but at least for the proof of concept, this Across was great for this. And this also worked in conjunction with CCIP, where Chaser would deliver information as to how to interact with these protocols. So obviously, like, one of the big hurdles was, how do we facilitate on-chain deposits into all of these different protocols? And so without getting too much into that infrastructure, CCIP was used to also help once funds are received from Across on the bridged L2, then CCIP also makes passes some data to facilitate these deposits. And yeah, that's it. So it was fun to build that, to build Chaser as a project, and I'm exploring developing it a little bit further. And if there's any sort of questions, I'd be happy to answer them.
Yeah, that's a pretty awesome presentation and awesome project as well, Michael. I'd like to talk a little bit later about how you came up with the idea and also about your future plans. We do have some technical questions, and Britt must have been reading my mind, because we've got the same similar questions. So I'll just read hers out, so it'll make it easier for me. In terms of the disputing and things, could we have like a dispute bot monitoring?
Yeah, no, absolutely. So that was one of the idea is that it's still like a measurable, and you can easily design a bot to do this. Like the strategy script that I mentioned, the whole purpose of it is to input as arguments, like, okay, the current pool and the proposed pool, and then you take those two arguments and you just run this script, and then it will tell you which pool is better. And so you could easily have a service that runs on a server and is monitoring every single proposal that's made, and querying the subgraphs that are related, and seeing like, okay, this assertion is objectively false. This assertion is objectively true. And so you could easily have that automated, and because it is the optimistic oracle is rather flexible with the execution environment. You could have it in a number of different ways, and you could have it as a bot that's constantly monitoring it, or you could have users running their own scripts. And so on both ends, for the asserter and for the disputer, you could have bots that are automating this and then opening disputes or opening assertions when appropriate.
Sure. And one of the things that was running through my mind when you were talking about it is, like you said, 1 minute, one kind of strategy could be, or return from a particular strategy could be more than at another time, like a few minutes later. So these things can happen really quickly. And it goes to Brit's point as well about the type of investments. So could it be set up for more kind of long-term strategies rather than things that you're chasing the best kind of APY for like 15 minutes, 20 minutes here, there, and everywhere?
Yeah, no, definitely. So it's so the basic, like, the whole idea is that you can take whatever data you want and really analyze it in whatever way to determine your preferred strategy. So if you wanted to, for example, like, not just chasing the highest possible yield at any given moment, you could also say, I want to get the highest possible yield at this moment, but I also want to look at that pool that you're proposing and say, okay, over the last 90 days, what was the volatility on this pool? And so we can measure with subgraph data, how volatile was this pool? And so let's say you have your deposits in a pool that is yielding 4% right now, but has been relatively stable. But somebody proposes a pool that's yielding 10% right now, but has been all over the place. And over the last 90 days, it has gone from 1% all the way up to 30%, but has an average of like 2%, right? And so you can measure with different statistics the volatility of this data set over the last 90 days. And so you can the strategy logic would compare these the volatility of these pools as well as the yield. And so if you are someone who's saying, I don't want to chase the highest possible yield at this moment, I only want to move my funds if there's a pool that has been yielding higher on an average over the last 30 days. And so you can definitely have more long-term strategies that perhaps aren't going to change in a matter of a few minutes. And so especially in those cases, a longer liveness period would be fine as well. So you can be very flexible in terms of like high risk, constantly moving, high volatility strategies, or lower risk, lower volatility strategies that are maybe only across the most reputable protocols. So it's very, very customizable, and ultimately it can be as the risk parameters can be what you want them to be.
Sure.
So,
and,
yeah.
And lastly for this time, and then we'll move on to the project, but please hang around because we'll have like a general discussion afterwards.
Yeah, definitely. No, I'll be here.
Yeah, great. So Brit says, disputers should only dispute based on the status of the world at time of assertion. Liveness window isn't meant to capture changing conditions. It's meant to catch faulty proposals. So maybe the assertion should capture a certain window of time leading up to assertion and then decide based on that. This would make it more clear what the dispute is meant to be focused on.
Yeah, and that issue can be resolved by just having a better, like a more clearly defined assertion, like saying at this given moment, that's what was yielding better. There would have to be some planning on like how, even because then even if the investment's no longer viable, then the assertion would still resolve to true in that case. But I would have to make some sort of logic in the smart contract to account for that case where, okay, the assertion wasn't a bad assertion, but this investment, we still shouldn't transfer to this new investment just because it's no longer the best investment, if that makes sense.
Sure. I notice we've got Lee here. Lee, have you got any technical questions for him? And then
just kind of adding on to that last point. Yeah, like the assertion has to be evaluated based on the time of the assertion. Otherwise, an asserter can make like a true assertion but still be disputed and lose their bond. And I think like shortening the liveness window, which if you have like scripts or bots that can monitor this, it's like fair to have a shorter dispute window that would mitigate or decrease the amount of assertions that were true at the assertion time but became false during liveness. Also, like what kind of strategies you target would also affect that too, right? Like a more volatile strategy could more quickly become not true during the liveness period.
Yeah.
The one other thing Britt pointed out is Across now has like this composable bridging feature, which, as I understand it, is rather than defining what address, or rather than solely defining what address the funds should be sent to on the destination chain, you also provide transaction data. So Across will deposit the funds into your target contract along with that transaction data so that you can automatically take, I guess, any transaction steps when your funds are deposited on the destination chain.
Yeah.
So that could be something, because I think you use CCIP for that in your hackathon, but it's a new feature that's coming out with Across, as far as I know, which would be able to do that as well.
Yep, you're not wrong, Lee.
Is this like brand new? Because like
actually, it's been in there for a while, but it's only now that it's being highlighted, and they've been doing some testing with it. So yeah, it's live now.
Can you all hear me?
Yeah.
Yes, we can.
Okay, I thought I'd be brave and see if my mic worked again. It is pretty brand new. Like it's been in our roadmap, but it just went live. And if you think you might want to use it, shoot me a message, and we'll set up a Telegram chat with folks so they can help you sort out how to integrate it. And also, if you're at if you are at DevConnect in Istanbul, you should stop by and talk to the team, because we're focusing on composable bridging there. So
yeah, actually, I remember I just saw on Twitter a couple hours ago. Like I am here in Istanbul, so I saw that tomorrow at the hackathon there's going to be like a presentation by Across, so I was going to be going to that. So
yeah, Dixie is the guy to talk to about how to get set up with composable bridging. So if you think that would be helpful, definitely stop by and talk to them.
Oh, that'd be awesome.
Okay.
Thanks, Brett.
Yeah, you should definitely stop by the booth as well and talk to Alex and Manny. Will be there. I mean, you had a great ETH Online project, but you don't have the chance to meet the team, and I'm sure they'd all be happy to meet you.
Yeah, definitely.
Are you hacking?
I'm going to be hacking, so yeah, I'll be going there tomorrow. So I'm pretty excited for that. I'll definitely stop by the booth.
Cool, awesome.
Cool. I'll send them a message to let's let them know that you'll be stopping by.
Cool. All right.
Okay, thank you for now.
Thank you guys for listening.
That's awesome.
Yeah, thanks, Michael.
And thanks for hanging on there, Mars. Are you ready to showcase your work?
Yes, my partner Richard is here on the call as well, and we can jump off and kind of give a demo of everything. He can take it away from here.
Yeah, so it's gonna be confusing because you've got my partner's account and me logged in at the same time. So we'll be doing it from my computer. So let me just go ahead then and share my screen.
Sure.
Give me a second. Okay, I'm getting some permission issues, so I'm gonna have to reboot Discord. And I'll be about a couple of seconds.
Okay, no worries. Wait for them to come back. So,
okay.
So Michael, there's I don't know if you've got the chat open. Oh yeah, you're typing now.
Yeah, there we go. So let's go ahead and share the screen. Cool. Can you guys see the slide?
I can.
You can? Perfect. Okay. I'm just going to say also that I've got a hard stop in 15 minutes. So I've got to kind of speed run this and then hopefully get the demo done in 5 minutes and then have some Q&A. But Swirl is the product that me and my partner created at the ETHGlobal New York Hackathon. So over the weekend, we conceived of this idea of a decentralized platform for crowdfunding for scientific projects. So it's kind of like neatly fitting into that category of DeSci. Now, right now, there are big problems with like funding. Researchers working at institutions and independent researchers struggle to get funds. Funny enough, the issue is it's more a misallocation. So the way the current grant schemes work is it's very restrictive, especially for independent researchers to try and get the funds. So we're talking here about like inability to get access to fund your research. A lot of really great ideas never make it to fruition because they just don't have the money for it. If we look at the main points here, we're talking about how we can improve the current system. One way of doing it would be having more of like direct involvement too. And what we mean here is, for example, like if I'm funding a research project as an individual or an institution, it'd be nice to have some kind of accountability procedures. It's also nice to have more transparency on where the funds are being spent. Like a good example would be charities. Like you put your money into a charity, and that's it. Like you put in the money, the input's gone, and you don't really have a great idea of how that money's being spent, if it's being spent well. And so these are the kind of problems that we're trying to tackle with Swirl. And we're doing this by essentially introducing a new model of relating scientific researchers to a new pool of investors. So these new pool of investors can also still include existing institutions, but also anyone with an Ethereum wallet, essentially, can now participate in funding scientific research. This will also apply to people that are existing in existing grant system. They might want to set up a second wallet on Swirl, receive some extra funding, or it can appeal to, for example, independent researchers who are trying to find ways of funding their projects without having to go through commercial grants or through university grants. So I'll show you in the demo how it works, but basically you can imagine it's almost like a kind of like an Airbnb interface, kind of like a marketplace interface. As a researcher, I create a project. So once I create this project, it generates a multi-sig safe, and this is safe. And then as a user, I can view these potential research projects and then choose ones that I want to donate to. Now, the accountability part comes in the sense that, okay, say you've created a scientific researcher's created a project and okay, they've received a lot of funds. Now they want to withdraw those funds, to buy some new machines, for example. Built into the system is an inability for the project owner to just take funds at will. When a project owner decides to withdraw funds, it actually issues withdrawal request, like a voting quorum. Now, everybody that donated to that project are called to vote. And this is where UMA comes in. We're using the snapshot protocol to create these voting quora. So say, for example, I've deposited some ETH to my research project. When the researcher wants to take some money out, I'm going to get invited to basically do due diligence. Like, okay, why is this person taking this money out? And the idea is to change the incentives or change the relationship between the researchers and the investors, kind of try and get investors to have more of an active participation in the research process itself. And we think that this has benefits on multiple grounds for both parties. It gives people that are investing more intrinsic value, like people who actually care about the project might want to have more involvement and see okay, well, how much progress is being made. And the researchers have to be more disciplined in how they work with their finances. Now, as a final kind of note to say, during the hackathon, we found something out about the nature of transferable safes. So I'll show you that in the demo. But what makes, I think, Swirl great is not just this voting system and using UMA around it, but the actual research projects, the safes that receive the funding, they're also transferable to through a token-bound account. So I'll show that in the demo. So let's go ahead. This is what the site looks like. Like I said, it's a simple landing page. We can see different kinds of research projects that people have created. And we're going to basically firstly sign in. Let's go ahead, connect the MetaMask wallet, and go ahead. Okay, so let's start a project. I'm going to say name of the project will be coffee, description, I need more caffeine. Okay, and then decide a category, let's say. Okay, now when we hit publish, it's multiple things are happening. So we're creating a multi-sig safe on Gnosis, and we're also creating a token-bound account. Now, why are we doing that? So basically, the safe that we create is signed by an NFT token-bound account. So we're using ERC6551 here. And the reason why is, like, if you ever want to transfer ownership of that safe, you can simply just pass the NFT to a different EOA, and then that person then has the capacity to have signing requests on that vault. And what this means is, like, if your research project ever needs to move between people, you can simply just send the NFT, and then you are the person now that can actually make these withdrawal requests and calls to vote. It's far simpler, like creating a new account and then transferring all the assets and all that. So everything's basically held in one NFT. The way I like to think about it is like it's having a hotel key card. So you have that key card and you just simply pass that to someone else, and now they have signing rights over the safe. So here's the actual multi-sig safe we created. And this is where we connect like the snapshot protocol. So once you have a safe, people can donate to it. And obviously when you want to then withdraw, then you have to make withdrawal request, which issues that voting system. The one thing I want to really show is just emphasize that point that the owner of the safe is this wallet here, ending in 1617. This is the NFT that we created. So it's the token bound account that we created over here, which we can see hopefully on EtherScan. This one over here. So once we've created the safe, we can go ahead and basically start sending funds to the user. So if we log out, I'm going to sign in as a user and not like a research scientist. So I've got a different account for that. Let's go ahead and connect. Okay, so we'll look at a pre-existing project about well-researched drones. You can see that we can see the amount of ETH in that safe, and we can also see like the project scope for the timeline. Now, when a user wants to donate some ETH, it will essentially, every time you donate, you'll receive a soul-bound NFT, and that basically proves that you are a participant in that project. Now, once you've done that, every time the owner of the safe decides to make a withdrawal request, for example, this research group wants to take out 2.5 ETH for a new drone, you're called to vote. So in this case, I can say, hey, okay, so in this liveness period, you've got 2 days. I can approve it or deny it. That's a very slow contribution. That was from the donation call. So in this particular like voting, I'm going to say, yeah, you know what, I think that they should have this money. I've done my due diligence. I know in the past that they're good with their money. They're very transparent about it. They listen to us when we give feedback, and we're like, you know what, I think this is something I agree upon, sign it. Again, this is going through to the Snap protocol here. So I haven't got a working example right now for this demo, but this is a previous series of test like voting core. But basically, we're using like the Zodiac plugin on the safe. So we can see over here. We're using the UMA OSNAP module on the Gnosis safe through Zodiac. And what that essentially does when we go back here, whenever someone makes a withdrawal request for this project, we'll do a subgraph call to find everybody with the soulbound NFTs, proving that they participated in this funding round, and call them to vote. So they get an invitation to vote. And that brings us then essentially to the voting proposals on the snapshot. And depending on the results, the withdrawal goes through or it stops. And that is like the withdrawal process as like in the most simplest terms in the MVP. Right now it's a simple majority. We didn't get time into looking into the details of like how we could make the the voting system more intricate to handle, like attacks and edge cases. So for this particular example, it's just a simple majority. Like out of all the people that participated, the 50% or more actually approve of the withdrawal request. Yeah. Okay. So just to show the side of the thing. Okay, we've got how many questions? Okay. Just let me finish the presentation a little bit.
Okay,
We're almost done. So I'm just going to show you now an example of how to create a withdrawal request. So I'm going to go back to the previous wallet I was in, the research scientist. So let's go ahead. Okay, and refresh, go back here. Okay, so the owner of the project has a different UI, and now they can say, I can withdraw or I can transfer. Each of these different things will create a voting round. So if I want to transfer ownership of this project, I'm like, okay, I'm either giving up or I'm passing on this research project to a different one because they've got more expertise, or we're merging. We might want to transfer all of the voting data, all of the historical donations, and keep that all on chain in one unified entity. And what we're doing with the transfer is essentially passing that NFT, that token bound account, which was created at the same time as the research project's vault. And that NFT has signing rights to the vault. So if I pass that NFT transfer to a different wallet, then basically that person I'm sending to will then be the owner of the research project. And everyone else that's a donator who's received those soul-bound NFTs proving that they invested in the project, they'll still have active rights to continue participating in the voting system as they have done in the past. Or I can choose to withdraw funds. So I can say, hey, I want to take some money out to withdraw, buy new machines, buy new drones, which again will create a new voting round using the snapshot protocol, invite everybody that was given a soul-bound NFT, and based on the conclusion of that voting round, the money will actually be transferred or it will fail. So it's kind of a quick demo of what we built on the hackathons. But in terms of question and answer, I guess we've got about 5 minutes, so we'll go ahead.
I love this idea, by the way, because I'm a security researcher, and getting funding is one of the big things. So I love this idea. And yeah, we do have some questions, and it's all from Brit. Do investors have recourse to remove funding?
They would be able to. I think what we could do is just have a different type of withdrawal request system specifically for that purpose. I think would be very useful. We didn't have time to scope that into this MVP, but definitely I think should be in the final product.
And if you give more to projects, do you are the votes proportional to the donations?
Again, I think it should be because there are dangers, right, with people hacking projects. Like if you could just spam create a bunch of external owned accounts and donate tiny amounts of ETH to accumulate votes. So it would make sense to make it proportional. When I've had conversations with other people in the space, they're like, yeah, maybe use some kind of quadratic voting as well as part of this. Again, I couldn't scope it into the weekend project, but it was something that definitely I was thinking should definitely go in the final product. Yeah.
Indeed, yeah. We sometimes forget you've got a couple of days to do all this.
Yeah, we had 40 hours.
Yeah,
something like that. Or 36 hours.
Yeah. I've got a couple of comments. Nice, and I like that NFT idea. And actually, I had no idea that you could do the NFT with creating safes. That's awesome. That's something new I've learned.
Yeah, this is something that we discovered actually during the hackathon, kind of by accident, and we were pretty excited by it too. We think that this has novel uses, not even particular in this project, but anyone in this room right now, I'm sure, has different ideas of how this could be used.
And you could transfer it as well. It's
exactly. So you have a complex research project with large amounts of money, lots of voting rounds associated with it, and it makes it very simple to just pass that on to someone else with the accountability, with the simplicity of just one transfer between two EOAs.
Indeed. Brit again, talking snapshot setup, is this a single Swirl space with several subspaces, one for each grant, or how do we prevent cross-voting between donors between pools?
Yeah, the idea would be to have like a separate space per project. Again, like in this, didn't have a time in this case, we just created one global space just to simplify things for development. But yeah, in the real thing, when you create a project, like I showed earlier, you would create a unique space for that project.
Yeah, and Lee was saying a non-confidence vote initiated by investors that withdraw funds to investors.
Exactly. We were thinking this is actually one of the main things we thought about right at the beginning. It's like, well, imagine if like the thing goes bust or there's some kind of scandal involved or the person just goes silent. We need a kill switch to end a project. So right now we're just using like a timestamp, but obviously the real thing would be more complex. But once the kill switch is activated, all the funds in that wallet should be redistributed back to investors proportionate to what they put in. So like say for example, like the total amount of the safe has gone down by 10%, then you're going to get 10% less than what you originally put in. But the idea is that there's an element of safety involved. So like now if I'm going to give money to this research project, I know that built into that smart contract is this rule that if there's any foul play or if the research project goes off the rails, I will get most of my money back. And again, we couldn't scope that into this project MVP on the weekend, but I think it's definitely doable. It's definitely on the roadmap for the idea for the product. Yeah.
Yeah, that leads to the last question. Really, is the future of this project? I'd love this to come to fruition. Actually, what are your plans, if any?
So my partner and I, Marina and I, are both very much like excited by this, and we think that we're assessing product market fit right now. So we're talking to people in academia, we're talking to people in industry, and just basically gathering information, trying to figure out like is this really a problem worth solving? And the kind of evidence that we've had so far is that the answer is yes. So right now we're still in the late stages of that, like figuring out more about like legal structures and all the other kind of considerations that might come into play when you build something like this. But so far, like I said, yeah, we're kind of scoping the market, seeing if there is a potential fit. But a lot of, well, I'd say almost all the evidence we've picked up so far is positive. Everyone we've showed this to, and this could be people working as tenured professors as well as private researchers, and also people working in pharmaceuticals, for example. Everyone can see some kind of use from a platform like this.
Yeah, I'm a security researcher. I've got a background, academic background, and this would be awesome. Actually, I'd be personally interested in this. And also, I'm a folk. There's a lot of great minds here. You've just heard Michael from another hackathon. We've got Lee, who's an amazing brain, and we've got lots of other great people here in the UMA Discord. So it'd be kind of a way to sound ideas and things and getting people connected here as well. So we'd love for you to stick around.
Well, absolutely. Thanks for giving us time to kind of showcase this to you all. I'm not gonna lie, I haven't been too vocal on the UMA Discord, so I'm gonna try and make more of a presence there. But I'm sure like if I have any questions, I'll bring it up in the channel and try and just be more active.
Yeah, and Britt lastly says, at the end, doing great guests today, and I agree. Very excited to see where both projects are headed. Do you guys have connection to Gitcoin? Because that's what the thing I immediately thought of about Gitcoin.
People make no, we don't.
Yeah, it's something to look into because they have obviously their own API. Maybe something you could integrate with possibly as well.
That's an interesting idea.
Definitely, that's a good call. Definitely, we'll look into that.
I mean, happy to make any connections.
Yeah, and I'll be happy if, to connect with you guys more as well because this is interesting for me. And anybody has any last questions? Because I know you have to run. Does anybody have any last questions for them? Doesn't look like it. You're free to run away if you need to. But thanks for sticking around we are a few minutes over.
You can put it away. Okay. Yeah, thanks guys for sitting down and listening to us talk about Swirl. And thanks, Lee. We'll be in touch on Discord for sure.
Awesome. Thank you.
Thank you.
Thank you.
Ciao, guys.
Yes. Hey, Michael, the same questions for you. What kind of you thinking of for Chaser? Sorry.
Yeah, so it's definitely something I like I said, I've had this idea for a while now, and since there's some interest behind it, I definitely want to build it out and see what this project can become. So I've been doing some other like freelance work in the time being, but starting from December, I am looking to build this out. So I haven't since the end of the hackathon, I haven't put too much work into building out Chaser, but I have had some other ideas for design, and also especially just hearing now about this new feature that Across is releasing about the composable bridging. I definitely want to take this further.
Yeah, awesome. Lee, do you have any further questions?
I was just thinking, I'm not sure how you want to create new pools, Michael, but if you did want to have it in a decentralized way without it being fully permissionless and possibly spammed, or with strategies that maybe don't fit well, if it's permissionless to create a pool, it would even be interesting to use OSNAP so that you could have a community that approves new pools, that the rules are written correctly. These are strategies that fit with the approach of the platform and stuff like that. So you could possibly have like this incredible trifecta of OSNAP, the Optimistic Oracle, and Across all in one platform. It would be cool for me anyway.
Yeah, no, that is an interesting idea, because there are some aspects that I do think that there would need to be like approval on, rather than just permissionlessness. Like, for example, like each of these different protocols that we can integrate deposits into, there has to be one part that I didn't get into during the presentation is that there is a separate contract that needs to be deployed for each protocol to be made like backwards compatible with Chaser for receiving deposits and making withdrawals from those deposits. And the idea is that this contract, because it's incredibly sensitive, it would have to go through an approval, and especially like for an earlier stage project, doing it that as a making that approval based off of a vote would be very dangerous, just because there wouldn't be as large of a pool of people voting compared to UMA, where there's already a community that is that can make these votes and approve and verify that this isn't being submitted by a bad actor. So there's a lot of different points where it could use OSNAPs, where it could make those votes to determine whether or not this should be approved. So that's interesting. I'll definitely read more about OSNAPs.
Yeah, even like, I mean, I guess on a governance level for stuff like that, or like maybe like creating new pools, it could be useful, but it could also even be useful for existing pools. Like, say you have a pool that's earning yield on stable coins, and now one of the stable coins that was in the rules as a valid stable coin for the pool, now that stable coin is depegged, and this stablecoin shouldn't be used anymore. You could either like sunset that whole pool and have everyone transfer to a new pool that doesn't include that one, or you could maybe have some kind of governance structure that says, let's remove this stablecoin from this pool, and so it's no longer valid, right?
Yeah,
Because I mean, things move quickly in DeFi, and what might be an acceptable platform or acceptable token or acceptable L2 might not be in the future, right?
Yeah, and I could see how that would be useful to like outsource that voting to an OSNAP rather than like doing it inside of the stakeholders of a pool, just because the whole idea is that this is like automated investments, and so it's not you have to be constantly monitoring and voting to make sure that your funds aren't being deposited into a certain a pool that got hacked or something. And so I could definitely see that being useful, and even like doing it on like a protocol level, like having some sort of mechanism where okay, this protocol got hacked, or this token is no longer can no longer be used. There is some sort of issue. Therefore, we want to call a vote as to whether or not we should allow this across any pool. And so I could definitely see that sort of governance and voting being very useful for this, actually. So definitely I'll be reading up on the documentation and how that works, and I'll map that into the protocol design.
Yeah, sounds great.
Yeah, we're a little bit over. Just lastly, Britt wants to highlight that we do have an ambassador program, and you might be able to get some UMA for some dev-related work. And you will also have like a direct line to the developers. The best person to talk to about that is obviously Lee, because that's where he came from. And if you guys connect.
Yeah, actually, I'm interested. I'll definitely, I'll shoot Lee a message afterwards. Yeah, I'm definitely interested to learn more about that.
And of course, if you're in Istanbul, just drop by the UMA stand and talk to Alex and Manny. And also Dixie on the Cross. He's an amazing guy.
Yeah, planning on doing that, and also the presentation that Cross is going to be doing tomorrow. I'll be going to that as well. So
and make sure to pick up some swag. I don't know if they've got socks or anything or whatever cool stuff they've got.
I've still got the UMA socks from. I have the socks from DevCon. Yeah, from last year. Maybe are they different this? Are they different this year?
No, I've never had any socks yet.
Britt. No, I do think. I think they started doing like socks specific to each event. So I think there'll be some Istanbul themed socks, I believe.
Oh,
which
nice.
Sounds cool.
I'll definitely just stop by and grab some then. Sounds cool.
No?
Swag is always good. But thank you, Michael. That's an awesome project. It's amazing you did it in a couple of days as well. I'm always
No, thank you guys for hearing me out and learning about this project that I built, and obviously thank you for the for awarding me the prize. It's an honor to have that kind of to be awarded the top prize for that hackathon that implemented UMA. So thank you very much.
Indeed, thank you. And PVM says he's going to drop you a Guardian NFT for being our guest today. So
okay, yeah, great. Awesome.
Okay, awesome. Yeah, thank you, everybody. This has been an amazing learning session, and I'm glad we did, and we will do more in the future as well. So for now, though, thank you very much, and we'll sign off.
Okay, thank you, everyone.